today's lecture we will cover concepts which we have already dealt with before, which is network analysis. We'll do an exercise on this and then we'll actually apply it to the two-span bridge problem. So the objectives are basically to review network analysis concepts. We'll apply network analysis to the two-span bridge, and then I think there will be a lot of discussion which should come out of this, and we'll take the discussion forward. Now, do you remember this problem? This was given to you when we did the network analysis and calculation of floats. What I want to do first is to take this and solve it. Okay, so this was and I assume that you have given this, you have a solution to this, and you can help me do this as we go through the process. So let us take the network first. So as we draw an activity on node network, we have A with A, B, C. We have 3 activities. Let me get my notes on this so that we have A, B and C, and it is when you can see that A, B and C have no predecessor other than start. So if these are activities which these might be actually physical activities, it is always good to put a start which might be kind of a 0 duration activity, which is the kind of dummy which you will have in AON. Remember, AOA had other kinds of dummy requirements for dummy activities. This is the only kind of dummy activity you will have for AON, and from B you will have D as a successor, okay, E, F, and G has C. Okay, G has C as the predecessor, and when you go to H you have 2. Okay, you have A and C. Okay, moving to I has F and G. Okay, J has E and D, and finally we have K, which has all 3. So sometimes it's nice to have it aligned. So I'm going to move H a little further down here, so that we will connect it this way, and then we'll connect it from A this way, and then all these together connect to K. Okay, now we will go ahead and add durations to this. Okay, so we have, so the start is, we are calling it a dummy, so it's a 0 duration. Okay, A has a duration of, you can tell me the durations as we go, 11, B 3, 9,
D has
7,
E has
9,
F has
5,
G
5,
H 19, J 17,
I5,
I 5,
K3.
and K 3.
good. Okay, so now we will, what is our first task? The forward pass. Okay, the forward pass. And we are familiar with the terminology. So this is calculating the 0 is the early start, early finish. Okay, now we go to the successors, and remember the 0 here and the 0 here are different points of time, but one is finishing, the other starting. So here we have 0, 3, 0, 11, 0, 9. Okay, move on to the next one. D is 3, 10,
E11,
E is 11,
20,
20,
F11,
F is 11,
16,
16,
G9,
G is 9,
14,
14. Good.
H11.
Now we come to H. H has two predecessors. It has 11 and 9. We take 11 because it's the later one.
30,
Finish again.
I,
Okay, now we come to I.
16,
We have 16 and 14,
21,
21.
20,
J, okay, we have two predecessors. One finishes at 10, the other at 20. We take 20
37,
and 37. So K has three predecessors J, I, H, and we would expect it to take the later value 37, finishes at 40. Okay, so the project duration is 40,
40 days.
and the sequence of going the forward pass, we have completed the forward pass. Now we will actually go to the backward. So we start with 40, we are keeping this fixed,
37,
and we come back to 37. Okay, so this is the late finish and the late start. Now we need to go back as to, so when is the latest J can finish?
37,
37,
so
20,
20, I 37,
37, yes,
32.
32,
37 minus 5, that will be 32,
H
and
37,
again 37
80,
and 80. Okay, so this is the latest finish, latest start. Now we go back again, so we can find E should not
E is
20. So if what happens if E exceeds 20?
J gets delayed.
Project gets delayed.
J gets delayed, project gets delayed. Okay, so that is the definition for us in order to the, for how late can the activity start or finish so that the project does not get delayed. Okay, so D again will be here 20, 20 and 30. Okay, so E, now we come to, now E is 20 and 11. We come now to F, 32
27,
to 27.
J is 32,
G, now G has
18.
two successors, I and, I'm sorry, not G, that was this. Okay. Okay, so G has only one, that is 32
27,
and 27. Okay, now we come to C. C has two successors.
18,
Okay, one is
22,
27,
27,
one is 27, the other is 18. So we take the
18,
Plus one.
the least, the minimum value. Okay, so we go to 18, 9. Okay, now remember, it's now A has three successors, E, F and H. Okay, the least is 11, 0. Here we came with, there's only one successor, 13, 10 and 0, 0. So we have finished the backward pass. And the, yeah, so now we look, when we look for the critical path, we have to identify the activities. We can make this network like this, it's quite simple. We can see that it goes to AA, E, J and K. Okay, and we can make out, we know that from the analysis, if my early start and late start are the same, then that would be the algorithmic way of finding the critical activity. Okay, and so all of these activities are critical. So this we did the basic network analysis, found out the early start, early finish, late finish, late start. We found the project duration, we found the critical activities. Any questions on this? I think this is fairly straightforward. Now we come to the floats. Okay, so remember how many floats do we have to calculate? We have total float, free float, interfering float and independent float. Okay, so we have 4 floats, and let us see. I mean, in a network like this it might still be possible to visualize especially total float and free float, but as you get into an interfering float is little more difficult to visualize but easy to calculate. Independent float requires quite a bit of looking through and finding out what has, what doesn't have. Let's go through that exercise. I'm not going to make a table, I'm just going to see, we have all the numbers here, so let us just work it out as per what we have here. So we certainly know that all of these values, what is the float of S, A, E, J, K? All 0. No total float, no free float and nothing, none of the other floats. Okay, when we come to C, let's start from this side. When we come to, let's take B of course, total float 10 days. So we have a total float of 10 days for B. Okay, I'm going to write the total float here. Does it have any free float?
No, 0.
No.
0.
Why doesn't it have any free float?
If B affects the
Right.
If B
Any delay in B will affect D.
D.
Okay, so there is no free float. I'm putting free float as 0. What about interfering float?
10.
10. Okay, 10. Any independent float?
0.
0. Okay, because any change here will affect B, and we can find what is the if you want to apply a formula for independent float, what is it?
Late start of
Early,
preceding activity.
No.
Late finish of the previous activity.
Late finish of the
Preceding
previous
activity.
okay, previous activity, the predecessors, and early start of the successors.
Minus
So
duration.
yeah, minus the duration. So I take 3 minus 0 and minus 3. So it has no independent float. Okay, so similarly let's go to C now. Okay, total float
C has 9.
9, free float
0.
0, interfering
9.
Independent?
0.
0. Okay, we go to D. 10. Okay, free float is 10. Okay, now let's how does D have free float of 10? Yeah, any delay in D will not affect J. So this is a characteristic, and the characteristic of the network is you find D is immediately preceding a critical activity and it's not critical. So there is, even if D gets delayed, my critical path is what is controlling the network. So it will not delay J. It has free float, and so if D has free float, how come B doesn't have free float?
The late finish and the late start.
Yes, whenever I move B, D, so free float belongs to only the activity. Okay, the total float, so remember when we talked about total float, B has 10 days, D also has 10 days. The minute I start using up the total float of B, what happens to D? D's total float also gets compromised, used up. So total float, like we discussed last time, is a shared float. Free float is not shared. So D has a free float of 10, interfering float 0, independent, okay, yeah, 20, 13, 7, 0. Okay, let's go to F. No, actually where are we? No, E is of course critical. Let's go to F. 16. Okay, now any delay in F will delay I 0. Okay, interfering is 16. Independent 0. Okay, we can see, in fact we have two successors. We take the minimum 11. We have only one predecessor, and in fact you look at interfering independent is when you do algebraic computation, what value do you get? It goes into a negative value. Okay, but you would say 0. G 18. Any free float? 2 days of free float. Okay, so we have now 14. Even 2 days will not delay I, so that's 2 days of free float. Now notice here we had D having free float because it was converging into a critical path. How is G having free float? It is converging into a path that is more critical than the path through G. So there is a buffer. That is how it has a 2 days of free. So interfering 16, independent 0. Okay. So that's again negative 0. We come to H, 7. See, free float of 7, 0, 0. Okay, I 16, free float 16, 0, 0. Okay, so through this we have solved the all the parameters we are looking for. We have solved. Are there any questions? So this was basically to refresh what we had done on the float and the network analysis. We would really like to apply this into the bridge. So we just did this as a review. Any questions? Yeah.
What is the influence of negative float? I mean negativity.
Yeah. Basically, what if we look at what that means, it means that algebraically it's negative, effectively it's 0. Okay. Now actually looking at a physical meaning of what it means is, at least as far as application is concerned, it means 0. As far as what do you say, the concept of a 0 float means that there is something in this network which is, if I start pushing back on this will require to go even further back on what is happening. Okay, so from what do you say, a project manager applying 0 negative float is just 0.
If the predecessor activity is finishing late and the succeeding activity is starting early,
right,
then we don't have enough space for the duration
right
itself.
Right.
So but if that is the case, then the activity has not got anything to do. I mean,
no,
the activity will suffer itself.
The activity will suffer. What do you mean by suffer?
Suffer in the sense it won't be getting finished even.
No, so that will delay the project. Yeah, so we are going to assign it a 0 of independent float. So it's independent, numerical value 0. What you are saying is we cannot afford to have that happen. But might be the point you are saying is that even if it is 0, so even if I take it as a value of 0, it's going to run into problem, right? So that's what. So concepts like independent float are not used in this perspective or in the application perspective, but what we probably have to do is to analyze so let's take one of these with independent float, with a negative independent float. Yeah, G has how many days?
G has 5 days. But I mean,
no, G goes to, if we take the numerical value, it goes to minus 5. Okay, is it minus 5? Where are we? We are 32, no, 16 minus
16 minus 18.
minus 18
Minus 2 minus 5 minus 7.
minus 7. So how would we physically interpret it? I mean, it's even more negative than the duration, which means if so all I'm saying is I cannot afford C to go to the latest and I to start at the earliest. That would be the most general interpretation that I could come up.
It doesn't show up as a critical activity also.
It doesn't show up as a critical
That's an
activity.
important thing. I guess
Okay, so in fact that's interesting. We should probably see, I mean, if you look up on papers or on research in this area, there isn't that much written on independent float. So might be this is something we should do in terms of looking at networks with independent float crunching and seeing what happens in the real life situation. But as far as most applications go, independent float is not even calculated. Okay, so in fact this is something one of you could take as a lookup for your term paper on how is independent float affect the project. Okay, so this is what we had wanted to fill up, and you will find that all the calculations we have done are in these slides. I am not going to go through it in detail, it is there for the record, and we have gone through the critical activities and all of the calculations which are associated. Now what I would encourage you to do is to use a bar chart to draw these, not now, okay, I don't want you to do it in class, but you'll have to draw this and see if you can visualize the various floats we are talking about. Okay,